Okay, I think, right, if you look at question 13, most of you have no issue with question 13. Most of you will know that these two lines are perpendicular. So you should have chosen 10 and 24 as the base and height. Okay, so you should have chosen the 10 and 24 for the base and height, and it should give you 120 as the area. Don't forget about your units, and please label your A, B, C. Okay, and thus can you go on to the polygon part, the angles also? Okay, then the difficult part is actually on part B. The difficult one is actually on part B, because the length of BD. So a lot of people, they can be stuck. So the method that we are going to be using here is another area. We are using another 90 degree here. So you must realize that BD is perpendicular to 26. So this can be a base and height. So which means, right, I can find the same area using BD and 26. So I can find the same area using BD and the 26. And these two area is supposed to be the same, because we are talking about the same area. So essentially, these two should be the same. So 13 times BD should be equal to 120. And BD will be 120 divided by 13. So if you don't get a nice number, that's fine. You can leave it in fraction if you can. So we are looking for the 90 degree. So for the first 90 degree is on 10 and 24. So that's how you find your usual area. But because there's another 90 degree, BD and 26 are perpendicular. So I can use the BD and 26 to calculate the same area, the same triangle. So there are two different ways of calculating the same triangle, and they should be equal. So there are two different ways of calculating the same triangle. And through this, right, we can find an unknown length. So this method is what I will call Delise, you can, but I think your presentation needs to be clearer. You need to make a person understand. Yeah, you can. Okay, so this method, right, I will call it the same area method. Okay, it's the same area method. This method, right, is it only applicable to triangle? No, it can also be applicable to parallelogram, rhombus. In exam, you will have unknown length in parallelogram, rhombus, which will be what you are going to learn today. So most of you will be learning this today. And trapezium also. Okay, so this one is called the same area method. And there is also another name for this one. There is also another name for this line. This line is also known as the perpendicular distance from B to AC. This line is also called the perpendicular distance from B to AC. So sometimes they will phrase it in this way. Okay, so please process the idea. The next two questions is the same idea. The next two questions will be the same idea. And thus, can you make sure you check the teaching worksheet 3 for angles? Because after this, you need to take a short rest, and then you will be doing a short test. Okay, the next question is the same thing. The next question, the first part is actually quite easy. You will realize 5 and 4 are perpendicular to each other. So your area will be 5 and 4. You will be using the 5 and 4 to find the area because of the perpendicular part. Okay, so the next one, right, you realize that they talk about the phrasing. They talk about the phrasing here, the perpendicular B to AC. So B to AC is here. So some of you may not even know where is it. So this is the B to AC. I'm going to call it K. Okay, maybe I should make it darker. So this is the perpendicular. Can see? So this is the perpendicular that they are looking for. And this is perpendicular to 12. So K is perpendicular to 12. I can use it to find triangle ABC. I can use it to find triangle ABC. And their area will be the same. They are the same area. It's just that I'm using different 90-degree. Okay, again, it's the same area, but I'm using different 90-degree. So please take note. Sec 2, you need to use. Sec 3, you need to use also. So you need to use this idea all the way until upper sec. That's why I'm emphasizing it today. Huh? So the next one, right? Maybe it looks a little bit different, but it's actually the same thing. The next one, they gave you an area here. They gave you this whole thing to be 84. So this whole thing is 84. And that should help us to find PS. Because PS is perpendicular to this whole length. Don't forget to add up. Some students will forget to add up. So you need to realize PS is perpendicular to 24 centimeters. So which means half times PS times 24 will give the 84 centimeters square. So you look for the 90-degree, which is perpendicular. So I will have 12 PS, and then to find PS, I just divide. And don't forget to put units. Okay? So the last part again, right, is the perpendicular idea. They wanted me to find RT. So RT is perpendicular to 17. So if you check out, RT is perpendicular to 17, meaning if I use half RT times 17, I will get the same area. I will still get the same area because it's still perpendicular. Then from there, you can solve accordingly. So this part becomes the 8.5. And then you divide accordingly. So I will call this the same area method. So if the answer is not nice, it's okay. If the answer is not nice, in O-level context, it's 3SF. Okay, in O-level context is 3SF. So this whole thing, right, I just happen to use 3 triangles to show all of you. It can be applicable for parallelogram. It can be applicable to rhombus. But commonly, they like to test on triangle. Okay, so this is what make, so some students, they can get very stuck. They wouldn't think of the idea of same area. Okay. So look for the 90 degree, different 90 degree, but they give you the same area.